Hey guys, this is our review for gas laws and solving for gas laws using our equations that we've been given. So for these problems, the expectation is to always show in your work, including the proper units, identifying your givens, unknowns, and equations, right? So it's not just writing that final answer. You have to show me how you got there. So to start, we have our three laws that we've talked about: Charles' law, Boyle's law, and Gay-Lussac's law, each one talking about different variables. Right? So the first thing we have to do in any of these questions is to identify the givens and unknowns. Then from there we can figure out what equation of the three we're going to use, isolate that unknown, and then calculate and solve for our final answer, all the while making sure we're using the correct units and keeping the units in their proper spots. Okay, so I have a few questions marked out that we're going to go over together, so you can kind of use this to help understand or kind of check your other answers and the setup for them. So we're going to do number 2 first, which reads: a sample of helium has a volume of 52 milliliters at a pressure of 75 millimeters mercury and a temperature of 18 degrees Celsius. When the volume changes to 63 milliliters and the pressure stays the same, what will the new pressure be? So there's a lot to digest there. So I'm just going to kind of start highlighting things I think I'm going to need to know. Okay. Pressure stays the same. So let's start with our givens. So the first reads: a sample of helium has a volume of 52 milliliters. So anything in milliliters, that's always our volume. And since it started off at that, that's our V1. Our next one says P1, or has a pressure of 75 millimeters of mercury, Hg. Right, mmHg is always a unit for pressure, and a temperature of 18 degrees Celsius. Right, and we can convert that into Kelvin, and we need to convert that into Kelvin for gas law problems by adding 273, which will get us to 291 degrees Kelvin. In the next half, when the volume changes to 63 milliliters, okay, so that is our new volume in this system, so that's going to be our V2. And then it says, and the pressure stays the same. Now that's important because that's telling us the pressure is a constant variable and it will not be impacting the temperature of this equation. So we're actually not going to need pressure in this problem. You write down the information you have, right? You write down P1, but it turned out you don't actually need it. So you have to be careful with stuff like this because sometimes there's little wild goose chases, or you just start plugging in numbers and you don't really know what you're doing. You're just trying to solve the problem. You're trying to get an answer to make it seem like you showed enough work. Be careful. Make sure you do this with intent. Make sure you know what you're looking for and know how to get there. Would ask, what will the new temperature be? So that's going to be T2. Right, that is our unknown. So we're going to leave that blank. So now that we have everything, we have V1, we have T1, V2, and T2, we can go back up to our equation and kind of like grocery shop, pick out the one that we need. So we have V1 and T1 and V2, and we need T2. So that's going to be Charles' law. I'm going to go ahead and just write that again down here. All right, V1 over T1 equals V2 over T2. So now we have to isolate our unknown. In this case, that's going to be T2. So to do that, we have to, if it's being divided, it has to be multiplied, right? Because we need this T2 to be on its own on the top. So we're going to times both sides by T2. This will cause those to cancel out. And then we can see in the next equation, T2 times V1 over T1 equals V2. All right, and then we have to basically cross multiply and put those in different spots. So the T1 is going to go on top, and the V1 is going to go on the bottom. So that gets rid of these guys on this side. Again, we cross multiplied. kind of cleaning this up a little bit, we get T2 equals V2 times T1 times V1. We can substitute our numbers we were given here. So V2 is 63 milliliters times T1, which is 291 Kelvin, divided by V1, 52 milliliters. And we do that, and we get 63 times. We get 352.5, so we're going to round that to 353, and then this is temperature, so that's going to be our Kelvin. All right, so that's our T2. All right, and that makes sense, right? Because our pressure went, or excuse me, our volume went up, we know our temperature is going to go up. Volume and temperature are directly related. All right, let's do another one. A sample of nitrogen inside a rigid metal container at 20 degrees Celsius, and I'm just going to start writing in the numbers as I see them. So 20 degrees Celsius, that's our starting number. I'm just going to convert that right away to Kelvin by adding 273. It's placed inside an oven, which increases the temperature of the nitrogen. If the initial pressure of the nitrogen was at 3.01 or 3.0 atm, so pressure has 3 different units. It could be in atmospheric units or atm, kilopascals, or millimeters of mercury. And then it changes to 6.42. So our temperature just went from 3 to 6.42. That's our P2 atm once placed in the oven. What is the final temperature inside the oven? So we are trying to find for temperature again. This time we have pressure. So we can go back up to our list of equations. We are looking for things that have temperature and pressure. This is going to be Gay-Lussac's law. So Gay-Lussac's law is P1 divided by T1 equals P2 over T2. And we just did this with the last one, except with volume. Right. And if you want, you have to make sure T2 is on the top. Sometimes I see they don't multiply. Students don't multiply, and then it just kind of breaks down. But then P1 is going to go on the bottom, and then T1 is going to go on top. So we have T2 equals P2 on the top still times T1 divided by P1. Okay. We can, now that we've isolated our unknown, we can substitute in our numbers. And I substitute at the end because if you start moving the numbers around in the units, it gets kind of confusing. It's not, you can do it, but it's just a personal preference. So now let's see, P2 is 6.42 atm. Again, also this is a good reminder, always include your units when you're writing in your numbers. You need to make sure you are tracking the right things and you're assigning the proper measurements to them. So times T1, which is 293, divided by P1, which is 3.00. Let's see, and you do that, and you get 6.42 times 293 divided by 3. And you get 627. We'll keep it at that. We can see the units for ATM cancel out, and we're just left with Kelvin. So T2 equals 627 degrees Kelvin. Right, so always ask yourself too, like, does this make sense? What happened in this situation? Well, we went from 3 atmospheric units to 6, which means we're increasing temperature. So if we're increasing temperature, we're increasing the amount of times those molecules come into contact with the surface. The nitrogen comes into contact with the surface of its surroundings. So more pressure means those things are moving faster. So that means our temperature has to go up. And it does go up. It goes up quite a bit. And we see like our pressure got more than doubled. Our temperature also got more than doubled. So temperature and pressure are directly related to each other. Okay, that's important. Moving on to our final example for this video. We have a balloon contains 7.2 milliliters of helium. So that's going to be our V1. All right, hopefully the more you do this, the quicker you can kind of get at it. Pressure is reduced to 2.0. Now this is careful. I'm just going to put P here at first. 2.0 atm. And the balloon expands to occupy a volume. So that's our new volume of 25.1 milliliters. So to ask, what was the initial pressure exerted on the balloon? So if you pay attention to the wording of this, the pressure is reduced to this number, to 2. So that's actually our P2, right? That's our new pressure. We don't know what our original pressure was. That's actually what we need to solve for. And generally, if we have ATM, as we do here, we're going to be solving for our pressure in ATM as well. Okay, so this is volume and pressure. So we can go to our equations, and that's our last one, Boyle's law. So P1 times V1 equals P2 times V2. Okay, we're trying to isolate P1, so all we need to do is take that volume and put it at the bottom. So I get P1 equals P2 V2 divided by V1. We substitute that out. So P2 is 2.0, V2 is 25.1 milliliters, and then V1 is 7.2 milliliters. And you should get 6.97. And then again, what are we solving for? We can just take a look at our equation. Our milliliters cancel out, and we're just left with ATM, which is good because we're solving for pressure. So our original pressure, our P1, was 6.97 ATM. Oops, box your answer. All right, so this video can be helpful, especially when reviewing gas law problems, to see how you need to set it up. Again, I see way too many students who just get kind of confused and overwhelmed because there's all these numbers and variables and they don't know what to do with them. Break it down step by step. Find your givens, find your unknown. From there, you can find the equation to use and then isolate and solve for that unknown. I hope this video is helpful. I will talk to you guys soon. Bye.